So on to our next talk. And this is going to be, I'm delighted to say, it's going to be Sam Newman. He's going to be doing a talk on testing the boundaries. Now, when I was preparing to do this, I was thinking, okay, what's some sort of funny anecdote I can do to introduce Sam? Because now, he's a big hitter now in our industry. If you aren't aware of who he is, he's literally written a book on building microservices and is a very well-known sort of thought leader. And I kind of realized he's become so famous that he's actually now got stalkers, and that I'm actually the stalker. So bear with me with my little story here. So at some point in the noughties, Sam moved to Sydney, Australia, to work for a tech consultancy. And a few years later, obviously, I did the same thing. We both kind of lived, I believe, in the Redfern area, this is starting to sound a little bit spooky. Both supported the Rabbitohs, which is a local NRL team. Could claim because they had an English contingent, but still. In my defence, in the sense of the geopolitics of Australian sport, I'm more an AFL guy, but there you go. And then he moved back to the UK. So what did I have to do? I had to move back to Europe as well, to the UK as well. So there you go. There's more stalking. And I think the last time I met him, I think I'm calling his name out, probably freak him out. I think it was Oslo Airport a few years ago. And so I'm not sure how scared he is about coming online and giving his talk. I hear he has also had COVID really badly. I hope you're feeling better. I have also had COVID. I did not give it to you. I did not believe I was anywhere near you. So please do not blame that one on me. But a little bit about Sam. So he wrote literally the book on building microservices. If you haven't read that, seen that, it's I think second edition now, and it's basically the Bible on everything you need to know. He's been a strong advocate for contract-based testing and PAC from back when we were both in Australia and doing a little bit of circuit over there, the conference circuit. And also, I've always been, when I first saw Sam speak, which I believe was in Sydney, I think it was actually a talk on CMSs, which he probably has hidden really deep, far away now. But it was the ability to not only be a really engaging talker, for those who haven't seen him, I'm sure you're going to take that away, but more importantly, was to be able to take a complex problem and really break it down based around the context to sort of really bite-sized chunks that you could really understand. And I think he's done that brilliantly with his book and those who have seen him speak about microservices as well. So I'm going to hand over. I think he's going to take control now, and he's going to share his content. And I think you're all going to really enjoy this. So welcome, Sam.
Thanks so much, Elliot. I should probably explain why I support the Rabbitohs, otherwise known as the Bunnies. It wasn't because of the English contingent in the team. I was unaware of that at the time, but I got dragged along by my wife and the people, some of my colleagues. They said, we're going to a game. I thought it'd be good to get to know the people in the office. I just moved to Australia, and I got on there, and there was a player playing for the other side, a guy called Sonny Bill Williams, and he comes out, the Roosters it was, and some of the ladies we were with were swooning over him. And I found him only conventionally good looking and took an immediate dislike to him and the side he played for, and so therefore started supporting the opposition. And that is entirely why I supported the Bunnies at the time. Obviously now I've come to know that they are obviously morally superior in every way to the Roosters, who are basically, Dick Dastardly in our ongoing feud. But that's it. That's the only reason.
That is a good enough story for me. That is how all rivalries are born, right?
I know this was like a safe enough space to share that in, I continue to support to this day and get up early in the morning to watch them whenever I can. And I'm back in Australia next year. Unfortunately, I think we're missing the start of the season, but not a good season for us. But I should be here to talk about other things. But it feels there is a very strong Australian connection here, despite the fact we've got obviously a couple of Brits talking right now, but PAC very much started in Australia, coming out of real projects and a lot of conversations that were happening at that time. And so I think it's only fitting that even the Brit guy doing the talk has a very strong connection with Australia, being also married to an Australian. So there's that. So we're going to be doing a talk today about sort of testing the boundaries. And I want to just explain what this talk's all about, because it's not a talk to explain, this is what consumer-driven contract testing is, because you kind of know that, right? Probably. And if you don't, there are some awesome talks out there to watch. What I want to talk about here is something very straightforward, which is the context in which we use these ideas. So there's a lot of streams of thought happening at the moment, lots of different conversations about. We've got microservices on the architecture side. We've got things on, we've got things around organizational dynamics. So a lot of conversation, discussion about team topologies. And at the same time, we've still got the age-old problem of, oh, I changed something and broke somebody else. So I'm trying to bring together a whole bunch of themes here today in this talk. So we're going to dart around a little bit, but hopefully I'm going to take you on a journey that tries to explain, my mindset around where this fits in the current landscape of software development. And as mentioned, I have written some books in the past, but those are kind of unimportant. You can find out information about those on the internet. I'm easy to find. You type in Sam Newman and then you put in brackets, not the Australian arsehole called Sam Newman, and you close the brackets, because unfortunately I do have an Australian namesake who is a piece of work, I think is what we say here. But we're here to talk about another piece of work at the beginning of the talk, namely certified hottie from history, Frederick Taylor. So Frederick Taylor was the father of Taylorism, which was named in his honor. He was doing some work around the late 1800s, looking at how to optimize the production of various products. If you think about what's happening in the 1800s, we're talking industrial revolution type times. Intensive agriculture has resulted in us having lots of spare people, right? We don't need as many people to feed us, which means you have more people for things like standing armies and bureaucracy and politicians and scientists, and also manufacturing. And by this, you can see that I've read the first half of Guns, Germs and Steel, didn't quite finish the second half because there's a lot of stuff about agriculture in the middle and I got a bit bored. But this is what's happening, right? So we're getting more people making things, right? Trying to make things in a repeatable way, like pens or motor cars. And in this context, Frederick Taylor comes along and says, look, we've got all this work happening, but there are things that we can do to make things, in his view, better, more efficient. And I'm not going to take you through all of his thoughts because some of them are quite disturbing. But what he, what became Taylorism and then later became known as scientific management, from this, we have some nuggets of wisdom like this. The art of management has been defined as knowing exactly what you want men to do, and then seeing that they do it in the best and cheapest ways. It really stirs the soul, doesn't it? And this next one, a large daily task. Each worker in the organization should have a clearly defined task. So this obviously seems like a really bunch of bad ideas right here, right? So we're talking about, we're putting you in a little silo, we're giving you a little job to do, and you're going to be told how to do that job. And our driver here is about doing that basically as cheap as possible. And, to be fair, in the context in which these conversations were happening and this work was being done, there were lots of improvements to be made. And then it would be wrong of me to say that there were no sort of useful ideas that came out of Taylorism. But of course, a lot of this is being used in the context of manufacturing, where you would sort of try and break any process, any complex process down. The car looks complicated, but the attempt here was to break that down into a series of small steps where you had people doing a very clearly defined role where they didn't have to have too many skills, and they were trained just for that one job. And then that's the way the world worked. And now, obviously, this being such a bunch of really great ideas, we thought, let's copy it when it comes to the world of software. And we see all kinds of siloed mentalities around our software development processes. I mean, we can think, of course, of the classic waterfall process, where we first start off by gathering our requirements. So we would spend sort of 3 to 6 months finding out what we wanted the software to do. Then we would do the system design step, right? And this is where we would spend 3 months drawing a box that was the same shape as all the other boxes we drew on, but it would inexplicably take us about 3 months and still not be the right box. We would then have the developers write the code inside the box, right? Then, of course, we would do the testing. I'm a bit older than I look, but when I started developing, it wasn't assumed that developers had to actually test their code because, you see, we understood that in our heads, the code worked. So what we would do is we would write the code and then we would have other people who we would look down on test the code for us, okay? Because, of course, again, we have a defined responsibility. We do a job and we pass it on. So then we have someone who actually does the tests for us. And then once that's all done, we then actually, hopefully, release the code. Now, obviously, at this point, deadlines have slipped a little bit, right? So maybe we would ideally like to have done this in a 6-month period, but this would typically take 1 to 2 years. So I first started as a consultant in 2004, working at ThoughtWorks in the UK at the time. And I would say back then, most of our clients were delivering between every 6 months to every 2 years. And that was pretty normal for the industry. Lots of you might be quite newer to the industry, don't remember 2004. Some of you disturbingly may not have been born then. However, the key thing is that was not unusual back then. Now, of course, times have changed. We would still also forget lots of other things in this process as well, like usability would always come as a surprise. Oh, we want people to actually use the application. And security would also come in right at the last minute because, you know, again, I think security is best thought of afterwards. And we would refer to this process as waterfall, primarily because we had this idea of all of this stuff goes in one direction. There's no feedback loops in this. And you can't go back up a waterfall unless you're a salmon. The other reason it was called waterfall is because when you ride a waterfall, it's highly unpredictable, and it's quite possible that you won't make it to the end. Now, of course, along came Agile. We have the Agile Manifesto, probably one of the least worst manifestos in history, by which I mean it's still really good despite its age. This is 2001, and a bunch of practitioners came together to try and distill down their thoughts about how software development should be done. There were lots of people here coming from different viewpoints and different backgrounds. And there was an awful lot of prior art that was happening at this time. You had things like RUP and DSDM and all these other things, some of which we look at now and see in hindsight to be a little bit overly heavyweight, even in non views. But nonetheless, this set of principles that sort of enshrined Agile became a really useful sort of mechanism through which we could change the industry. However, unfortunately, an awful lot of people that looked at the Reactive Manifesto I don't actually think they really looked at the words. And if they looked at the words, they would look at the meaning. And so for an awful lot of organizations, what happened was they carried on doing waterfall, but all that happened was rather than it taking them like a couple of years, it took them like multiple months, which, look, to be fair, is still a lot better. Now, there are some principles in the Agile Manifesto that I think is especially important to still bear in mind, especially when we're in a conversation today all about the success of PACT, which is a tool. And so I don't want this to come across as an immediate slam, but one of those first enshrining visions for Agile is the idea of individuals and interactions as more important than processes and tools. Which is not to say that processes and tools are not important, but they are less important than the individuals and the interactions. Now, this is a mantra that I have to spend a lot of time saying. I say it's a lot when I'm working with people building out giant Kubernetes clusters for ease of use. And when they say, have you actually spoken to the people that are going to use them? And they're saying, who are people? What are they? Are they like containers? And there's always a danger when we have it going to be a testing tool space that we can often lose sight of the purpose of this. So what I want to talk today is about the purpose of things like continuous contract testing and how things like PACT can fit in that process. And I'm hoping that you'll see that it is actually all about the interactions. So let's look at other silos that we've seen traditionally in our organizational structures. We've seen the silos in terms of responsibilities, and we also see the silos crop up in terms of our architectures. The classic 3-tiered architecture, the universal architecture of truth. You could walk into any organization in the world as a non-technical consultant masquerading as being an architect, and you could put out your rubber stamp and say, what we need is our 3-tiered architecture: presentation, business, data access. So good they named it 3 times. It's basically what you see over and over again. Part of the reason it's so familiar, I think, is it's easy to categorize code, but it also, we tell lies to ourselves about this architecture, right? We pretend that we haven't put any stored procedures of business behavior in the data access layer. We sort of pretend there's no business logic in the front end, even though, actually sometimes having business logic in the front end is a really good idea, but we can't because of this model, but we do it anyway. But we also kind of align ourselves around this architecture. It's very common have different people working on different parts of this stack. We have the front-end developers. And you probably all know what the front-end developers look like, right? Because they've got those weird, funky haircuts and tattoos, and they think JavaScript's a real programming language. But they do know where all the best coffee shops are, so they do have some value. And then we have the serious people, the grown-ups, right, that use proper languages like Java and C#, right? And we talk a lot about things like enterprise integration patterns, and we know about message brokers and the like, and we definitely think that JavaScript is not a very good programming language without ever having actually done any of it or engaged with any of the problems there. But the important thing is we own lots of very big, thick books about technical topics. Some of us have actually read those books. And yes, you will notice I've snuck in a copy there of the second edition of Building Microservices because I'm not an idiot, and this is basically free advertising. This is available from all good and hopefully bad bookshops as well. So, we've always got the serious service developers where we do the services, right? And we have proper languages. And there's also the DBAs, but no one's not entirely sure where the DBAs are. I mean, we assume they're still alive because the database is still working, right? But did we see them last year? Or was that pre-pandemic? I think they're downstairs somewhere, right? Now, I'm poking fun here at some of the inherent tribalism that happens within software, which is problematic in extreme. But why does this even happen? Why do we have these kinds of weird siloed architectures with these weird siloed behaviors? What is going on here? Well, I think actually at its heart, a big chunk of this comes back to that looming shadow of Taylorism. Let's come back to observation we saw at the beginning. A large daily task. Each worker in the organization should have a clearly defined task. And this still pervades an awful lot of conventional management theory, even if there are at least lip service attempts to move away from this model. But fundamentally, we still have a tendency in IT projects, although it is changing, to group people based on their core competency. Okay, so we group people together. Front-end developers are with other front-end developers. Back-end developers are with other back-end developers. The DBAs are with other DBAs. And we do this because we want to group people based on their core competency, basically because that's what we've always done. And at the heart of this, there is this myth that you can break down the creation of software to a series of discrete tasks as though you're making, say, a pencil. But software is not a pencil, right? Now, this way we organize ourselves ends up driving these kind of oddly uniform architectures. This is, obviously we can come back here to Conway's law, the observation made by Melvin Conway back in 1968, that organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. What we're basically saying here is that how we organize ourselves, how we communicate with each other ends up driving our system architecture design and also implementation. And this link is being seen over and over again. There's been some great studies showing this out. So fundamentally, if you group people in terms of these discrete competency-based silos, you're going to end up with an architecture which is siloed around those discrete technical disciplines. And this causes a bunch of issues. One of the challenges here is how do you optimize this process? How do you make it do better, right? From a management theory point of view, what you basically end up doing with this model is optimizing for utilization. So you've got these developers in these different teams, right? And you say, well, how do I make this more efficient, for example? What happens if the front-end developers have got too much work? Well, it's easy because obviously these are very simple skills that any idiot could use. And that's often how workers are viewed in scientific management as, these aren't highly skilled jobs, are they? Oh, hell no. I mean, you don't have to be highly skilled to work in building a car, do you? I mean, turns out you do. But anyway, so we've got too much work for the front end. So what do? We just throw more people in because that's easy, right? It's very easy. You just open the door and just scoop up developers and throw them in. Say just more front end work. And you crack the whip. Likewise, you've not got enough work going on in the back end, and you say, well, we want to keep our costs down, so we'll just fire some developers, right? That's fine, because again, hiring them again when you need them in like 2 weeks from now is not a problem. Now, beyond the fact that this doesn't work very well in terms of the mechanics and the realities of working in a knowledge worker space, like software development, it doesn't work in the manufacturing sector either terribly well. But fundamentally what we're doing here is we're optimizing for utilization. What we're attempting to do is to make each of those teams 100% utilized. The problem with that model, of course, is that 100% utilization doesn't mean you're actually going fast. And let's examine that, right? Everyone's busy, but we're often busy waiting. How often do you have a problem where you need to take some data out of a database and put it on a screen? And with architectures and sort of these competency-based teams like this, you end up having to coordinate work through multiple teams. So if I've got to make a change in, say, the data layer and the service layer and the UI, simply to put like a new control or a new piece of information on a GUI, then I'm having to coordinate that change across multiple streams of work. This is leading to an awful lot of coordination. And look, we can talk all we want about fancy ideas and highfalutin distributed system architectures, but the reality is that I reckon that 75% of all software development is taking data out of a database and putting it on a screen. And if you're very lucky, you get to take that data off a screen and put it back in the database again. The other 25% is meetings, right? That's our lives. And so these layered architectures didn't seem to be optimized for the kinds of features that we would be creating. And when we were in an environment now where people expect software to be delivered more frequently, they expect new features to come out more frequently, these sorts of ways of working aren't really acceptable anymore, especially if you're building a SaaS-based product. We don't expect things to be, new features to come out once a year. We expect them to come out weekly. So what are the expectations are of society in general are not necessarily lining up to how we're organizing ourselves internally. And fundamentally, these types of architectures do lead to lots more meetings, right? Because you're having to now coordinate work. You're coordinating activities between teams that aren't lined up in terms of what they're working on right now. So if you like being busy waiting around, these architectures are kind of very much for you. So we started trying to improve things, okay? So this is the concept that predates Agile, but came to the fore during Agile, was this idea of, okay, let's actually get teams working together. This is what we called a feature-based team. And the idea here is you create a poly-skilled team that's going to work together to deliver a set of features. So rather than having people broken down in their core competency, which obviously would include, testing being done somewhere else as well. Instead, you'd pull together a team where you would have within that team the skills required to deliver a set of features. So you might have some generalists in there, you might have some specialists in there, but now the dream is that you can own the end-to-end delivery of a feature. This is something that collectively we are working on, and we are going to roll that change out. This also makes it much easier for you to have a sense of purpose. What you're delivering is more closely tied to the external outcomes. The other benefit of this model is that you have an opportunity to grow new skills. Sure, you might be a DBA, but sometimes the right thing to do in this moment to get this feature shipped is not to do some DBA work. Maybe you could help out with some exploratory testing, for example, or help in terms of looking at requirements, or learn how to do some infrastructure automation. This also creates an opportunity where you can grow generalists, but we're kind of moving away from I am a DBA, my job is to write DBA code, to my job is to help ship software. And I work as a team to ship software, to ship features and put them in the hands of people. I think we heard earlier from the Q&A, Beth was talking about the thing that motivates her is working on real practical problems, not theoretical things, or not things that don't ship, right? It's you have a problem, you solve a problem, and you put it in the hands of people. And this is something that is incredibly empowering, rather than being locked away in your silo. So basically, this idea becomes much more of a collective vision. We are working together to get this thing shipped. And creating environments in which it's easier to work together is vital. Kent Beck, in his new book, talks about software design being an exercise in human relationships. Fundamentally, software is, a software-based system is a socio-technical system, right? It's people and technology coming together. It is people that build the software. And only addressing the technical side of this means you're missing more than half of the picture. So finding better ways to work is great. The downside often with the feature-based team model is the fact that we're often working against the architecture, because often these feature-based teams are being applied on top of a pre-existing architecture that wasn't shaped around that organizational structure. Remember, we have this idea of the architecture is driven by the org structure. When you don't have that, you end up with tension. In this situation here, we've got 4 different teams working on different sets of features, but as you can see, they're all working on the same code. They're working across those same layers. And so you can now very easily have situations where one team makes a change that might impact other teams. So I do a change here, but you want to roll out a change there, and that's going to block you. And oh, that means that they can't do their refactoring. So although we would like these teams to be able to come up with the ideas or implement the features and get them out the door, the problem is there's still coordination between these teams needed. Before it was about, okay, can you do this DBA work for us? Now it's about, we all happen to be in the same part of the code base, and so we need to coordinate those changes. Those shared code bases become contention points. So this is kind of a really important thing to understand. If you have loads of different teams working to different schedules, working in the same piece of code, it is a pain to manage. In fact, one of the studies often cited in the context of Conway's Law, studies done by Microsoft, looking at sort of organizational dynamics in the context of their larger code bases. And they found, for example, through a couple of different studies, that areas of code that have a high ownership churn, with a high turnover of users, are much more likely to have defects, for example. Now, obviously, that's extrapolating just from Microsoft's use case. That's a pretty decent case study. You can look up that stuff online. I think I referenced them from the book. So we have this kind of issue. The other problem with feature-based teams as well that shouldn't be overlooked is that typically the vision for feature-based teams was there's them being a short-lived team. You would pull people together to deliver a set of features. And the challenge with that, of course, is when you have short-lived teams is, there's no incentive for you to make long-term decisions. When we think about something like technical debt, we often see debt as a downside. Debt is useful, right? When you're also the person that has to pay that debt down. So in the short term, we might take on debt to allow us to do something now. But if you've only got a short-term vision for that team, you're not thinking about the impact of paying that debt down, and you're not going to prioritize paying that debt down. So this becomes a bit of an issue. So we need to shift this model, and that's what's been happening. People think, well, we like this idea, owning delivery functionality end to end. The short-lived nature isn't great, and we also have this problem with everyone contending and fighting in the same part of the code base. And so what we've been looking at is, over the last sort of 10, 15 years, how do we shift the architecture here? How do we give these teams full ownership of their software? And this is where microservices fit in really neatly. I work with clients all over the world who are working on different types of problems, but the single most common reason why the larger organizations are moving to microservices has got nothing to do with they've got large scale in terms of amount of traffic or data, because enterprises rarely have scale issues. It's not because of latest technology. It is simply they want more organizational autonomy. They're big companies with lots of developers, and it's nowhere near as efficient as they want it to be. And so they want to move to a model where they have a lot more organizational autonomy. Now, obviously, the results of that, if you do it properly, is you end up with losing a whole chunk of middle management bureaucracy, which isn't something that people always realize at the time, but that's a separate discussion. So what we're aiming for here is a model now where we have teams that own services. So we have that, this is my service, I own it. So now I can think about the short-term and the long-term vision for this software. But I also can deploy that when I want. So now we have a model where we have teams being able to own changes end to end, being poly-skilled, and with a microservice model, being able to deploy those changes independently. Now, what's unwritten here is that I think this also should apply to the user interface. Wherever possible, I think user interfaces can and should also be decomposed along these lines. There are sometimes technical constraints that might make that challenging, but I think that should be the norm, not the exception. Unfortunately, we took a wrong turn about 15 years ago and started thinking that single-page apps were a good idea. I'm not saying they're not a good idea in some ways, but they were fundamentally designed to be monolithic in nature. And it's only really been in the last 5 years or so people have realized, can you break apart user interfaces? Because, fundamentally, the people that designed single-page app frameworks didn't understand how the web worked, and so didn't know about things like websites and had never built user interfaces in the past. I say this having known some of the people that built the single page app frameworks we all now use. We are now realizing that having giant monolithic user interfaces is not necessarily a good idea. And it's like, oh, well, let's retrofit in some ideas around this concept called modularization, which comes from the mid-1960s. But anyway, I digress. So we're now into a world where we're looking for teams that can drastically reduce the amount of coordination they need to do when releasing software. The inventory team are able to implement features and roll those changes out without having to coordinate with other teams. This in turn means you improve release frequency. When we're releasing things independently, we are reducing the batch size of a release. The release itself is smaller in scope. Smaller scope releases are easier to make happen. They're less likely to go wrong. Something does go wrong, they are easier to fix. If you reduce the batch size of your release, you will be able to release more frequently. This is not agile. That's just good old-fashioned lean thinking right there. And also we have evidence from things like the State of DevOps report, as outlined in the book Accelerate, that organizations which release more frequently also have lower regression rates and lower rates of rollback. So there's all good reasons why we should be doing this. This also then opens up the model where the teams that own these services can potentially to own the full life cycle of these services. You know, the whole you build it, you run it, you ship it model. That's not right for everybody, but this at least is now something that gets opened up with this shift in thinking. So this is all great. But one of the problems here, of course, is the changes that we make. This team here, the inventory team, is deploying a brand new version of their inventory microservice, right? Seems like a good idea, but we see these inbound arrows, right? Now, these arrows represent dependencies. This team here on the top left depends on the team providing this inventory functionality, because with a service-based architecture, we have this interesting, not paradoxes in a way, but maybe inherent contradiction. Because on the one hand, we want these things to be independent. We want to be able to change them independently to get all the good stuff we get. But on the other hand, fundamentally, our systems only exist because microservices collaborate with one another. So these dependencies here from the team in the top left on our inventory service give us pause for thought. I'm going to change that microservice. Do I still meet the expectations that my consumers have? Do I still do what they want me to do? Because if I roll out a new version of my microservice and it causes some sort of issue, well, what does that mean? Well, it potentially could mean a production outage. So a lot of focus then becomes into how do we catch these kinds of changes? When we are about to release, do we know if we are releasing software that is going to still work in a production environment? Now, I have a whole chapter in my book which explains why end-to-end tests are a great fix for this problem until they're a terrible fix for this problem, right? There's a journey you go on with them. So I'm not going to go through that again. So instead, I'm really going to jump to sort of how we're trying to solve these problems without using end-to-end tests. Well, the first thing, of course, in this situation is just don't break contracts, right? So, start from a viewpoint, which is we aren't going to change our APIs or our endpoints or our message formats in incompatible ways. We are going to look to expand. Adding new things should not break your clients. Adding new optional fields should not break your clients. If I get a customer payload back from a service and you've added on some new information, that should be fine. Now, if it's not fine, I would call into question the technology you're using for your communication and serialization protocols, or how you've written the clients, right? So that's this. We'll get this. You can look up the tolerant reader pattern if you want to know more. So from a mindset point of view, understanding that maintaining backwards compatibility in a microservice architecture is really essential. Otherwise, you don't get the ability to change things in a nice and easy fashion. So your APIs and things, you need to look at expansion changes rather than contraction. Contraction is where you start breaking compatibility. But we also need to create an environment where we can catch and eliminate the accidental breakages that occur. So assuming we've done our best to not break APIs, how would we know if we were going to do it? Now, I think broadly speaking, I break contract breakages down into two categories. I'm not sure if this is kind of other people's models as well, but I like to separate these two out. So I think one is more obvious way to fix than the other. And so I think we can split our breaking changes down into either being structural breakages or being semantic breakages. So to give you an idea of what I mean by structural breakage, this is where the shape of the information flowing changes in a way which is clearly not backwards compatible. So I might send you a payload, and I go from sending you, I send you a payload, and I've removed information you expect. Structurally, the stuff I'm sending you is now different. You might have a method that I call over, maybe it's an RPC interface, and I'm calling a method over a network, and it's a method that used to take 2 required parameters. It now takes a 3rd required parameter, right? That again is a structural breakage that should be pretty easy to pick up. And this is typically where I would use schemas, and I'll get into a bit more what I mean by an explicit schema. And schemas can pick those things up quite nicely. Then we've got the more tricky problem, which is the semantic breakage. So I go and say to a service and say, can you give me a shipping label for this package? And what comes back is a PDF that contains the shipping label that I can then give to a customer to print off or whatever else. But then you change that API, rather than it being a shipping label that comes back, what actually comes back in that PDF is a picture of your dog. Now, structurally, I can't see the difference between those 2 things. Semantically, one of them is good and one of them is very much not good. And so over time, I've done a bit of a 180 on this, right? I used to hate schemas. I now absolutely see their value. And so for me, this is why I like thinking about both testing and schemas together, because I think this way you kind of do the easy stuff with the schemas and you do the difficult stuff with the tests where you have that power. So I am really and I think part of the reason I was so anti-schema for a long time, and again, anti-explicit schema for a long time, is because I lived through the horror of SOAP, the Simple Object Access Protocol. Never has the word simple been less well used, where you have an enforced use of something like the WSDL schema, for example, right, which is you have to use as part of SOAP. And in fact, any RPC mechanism, pretty much Java RMI aside, it mandates a user-defined schema. So some technology protocols enforce a schema. The benefits of schemas are basically that you get that ability to pick up structural breakages in a pretty quick and easy way. They're not foolproof in that regard, and some tech is better than others. But if I change the interface for a service and I have to update the schema to reflect that change, there are tools out there that can look at 2 versions of the schema and pick up the easy stuff. You had 2 fields that were required. You have added a 3rd field, which is required. That is a backwards incompatible change. I know that's not all changes and that's not all breaking changes, but that's a bunch of the easy stuff that should be easy to pick up. And so we've got things like, the Kafka schema registry, for example. So this is an optional thing you can run alongside Kafka. So you can upload the schemas for your message formats, and it supports Avro, proto buffers. It might support JSON schema. I'm not sure. I think it does. And it will tell you if they're backwards compatible or not. Now, the great thing about that is, as a developer, that's feedback I can get at my laptop before I even check in. For me, the analogy here with the use of schemas and explicit schemas is data static typing to dynamic typing. So the statically typed language, your types are fixed at compiler time. So Java, C#, for example. What that means is if I try and call a method on an object that doesn't define that method, the compiler errors. And so I have to fix that as a compilation error. With a dynamically typed language, the types are fixed at runtime. That means I don't know until I actually run the program whether or not that method is actually going to exist. So that means that when I'm trying to verify my programs, whether they work, part of my test burden with dynamically typed languages is there for typing issues. Now, I love using dynamically typed languages. That's the stuff I use mostly for now with my own code and things like that. However, I see the value in that fast feedback of static typing, especially when the impacts of getting it wrong are so great. And so around those service interfaces, I think there's a lot to be said for using things like, Protolog for gRPC endpoints, or using OpenAPI diff if you're that way inclined. I said the word explicit schemas here a lot. And lots of people saying, well, I don't have a schema. I just send JSON over HTTP. Well, you always have a schema. The question is whether or not your schema is explicit or implicit. When you send just plain old JSON over HTTP, beyond the fact that, it's probably not REST, the recipient of that JSON payload has expectations as to what that payload is going to look like. They expect certain things to be there. They expect a name field to contain a string type, an address field to contain a nested JSON collection, or whatever it might be. The difference is when you send it, you don't know what those expectations are. That is the schema to a great extent, being a subset of the overall contract. So, I think both consumer-driven contract testing and schemas are about making what is implicit explicit, and making it explicit in a way that we can verify if we've broken those expectations. And I think we can and should do schemas for the same light as we do, say, contract testing. So that then leaves us with the contract testing to solve the really difficult, hard problems here, which are, okay, are the semantics of this service what I expect? So fundamentally here, the places where these things become useful, most useful, is then in the interface between teams. When we're communicating between ourselves, we are having conversations about how things should work. Now, actually, when this stuff works, you actually reduce the amount of coordination and communication that happens. And what you're left with is the communication and coordination that should be happening. The conversations between the team in the top left and the team in the bottom right regarding the interactions between their services. It is right that the top left team who own returns and shipping do have conversations with the inventory team, partly to say, well, I'd like your service to do this, but also to agree things like SLOs. I've long been a proponent in thinking of service design in a consumer-first mindset. One of the big issues around microservices is ensuring that they can be changed without causing compatibility issues. One of the big ideas here is to use this concept called information hiding. You basically hide information behind your service boundary. The idea being anything you hide inside your service boundary can be changed safely and easily. This is another cutting-edge idea. That's this one coming from 1971. The problem often, though, when you come into creating a microservice is, well, how do I know what you should hide? And often the reason people are struggling with this decision is because they're thinking inside out, not outside in. So we have a situation, this can often occur when you're creating a service ahead of other people needing it, or in an environment where you're not that bothered about finding out who your consumers are. So I'm building a service, I know I've got some data in a database, I know I'm going to have some consumers at some point, but I'm not sure who they are or what they want. So in the absence of actually knowing who my consumers are, I'm just going to guess. What's the safest thing for me to do to cover all bases? Because remember, I probably don't have to come back and rework this later on. Well, what I'm going to do is just grab whatever I've got in my database and stick it on the API. Okay, it's sort of one-to-one mapping. My data model becomes my API, because you didn't know anything better. And now basically your consumers are now coupled to your internal data model via a really inefficient wrapper on top of SQL. And in this sort of situation, people say, oh, yeah, but we don't know who our consumers are, so we don't know, well, we couldn't do anything else. I'm like, well, if you don't know who your consumers are, how can you decide things like what acceptable uptime you've got, or, how much load you're going to handle? You can't at the same time talk to me about SLOs and not know who your consumers are. That doesn't work. So there are all kinds of downsides with this model, right? The first thing is we're basically not hiding the database. This is information hiding in the same way as having your fields being private in your object, but putting public getters and setters on it. Distressingly, there are now multiple products on the market that will instantaneously give you a GraphQL API just by mapping your database straight to GraphQL. And at that point, I'm like, why do that, right? If you're just going to integrate a database, talk straight to the database, because at least then you'll be using an appropriate query language. And also, OData is a thing. Anyway, and the other issue with this model is beyond the fact we've now basically coupled our external API to our internal implementation. Do we think that is a nice and easy to use endpoint? Do we think it's going to be pleasant to use? What we end up with is an API that models our internal implementation detail, not an API that is built and designed to make our service easy to use. And look, microservices exist to be called. Their job is to be called by other things or to call other things, and that's it. They're either being called by other microservices or user interfaces and the like. You need to treat your microservice endpoints like a user interface. If you were going to create a graphical user interface for your customers, you would go and sketch it out. You'd have a conversation with them. You'd tweak it based on their feedback, iterate it a few times because you want your users to be happy, don't you? Because otherwise you'll go out of business. But in a microservices architecture, we are creating endpoints that other people will have to consume. We are creating user interfaces. These are internal users, and they're called developers. So in this situation where you create a graphical user interface that maybe a customer doesn't like, you don't necessarily know who that customer is. They might be effectively a faceless entity to you. There's a disconnect between you and them. It's not nice, but it happens. But when you create a microservice with a really crappy API, just because you couldn't be bothered to have a chat with the people that are going to use it, you're creating a bad user interface that's going to be used by people who know who you are and know where you live. Doesn't seem to make much sense to me because many of them have a very special set of skills and they will find you. Instead, we can solve a bunch of these problems by inverting our thinking. Start by thinking consumer first. I mean, consumer-driven contracts go back to the mid-2000s where we were trying to formalize having conversations between consumers and producers. And the original stuff was like, not testing, it was like, let's actually talk about what you want and design the API together. It was co-design activities. So start from the viewpoint of going, it's not an amorphous consumer, it's a specific consumer or a group of specific consumers. What do they want? What do they need? Because not only do you then come up with an API which is nice and easy for them to use, right? Making their lives better. But this is also how you establish exactly what you need to expose and no more. So if you're struggling with concepts like information hiding, go outside in, only expose what's needed, nothing else. This will really result in the interfaces you're designing, the endpoints being smaller in scope and more stable. And the less stuff going on in your API, the easier maintaining backwards compatibility is. So when we've had this conversation, and it should be a conversation, right? We have had a conversation, we've designed it together. Things like the schemas and the contracts test that we come up with, they're a representation of that discussion. They're a representation of the relationship between those teams. And that relationship will be ongoing. So where things like contract testing fit into me is a living representation of that agreement, but also an ongoing part of the dialogue we would need to have. I think it can sometimes be a mistake because of how good Pact is that you don't actually have to have conversations with the people they just come up with new expectations. I think we can be better than that necessarily, but at the very least, something being checked in and owned by another team, they know who we are. Software design is fundamentally an exercise in human relationships. And I think if you really want this lovely new vision of autonomous teams that can, go fast, we need to be explicit about our boundaries and have the right kinds of conversations with the people around us. It starts, though, with those individuals and interactions, supported by the best tools and technology out there to make it work. But it does all need to start with a conversation. That's me, because I figured it might be nice to have time for questions. And I knew I was going to be quite ranty this morning, so I thought I'd better leave some extra time in case I was going to get censored. But yeah, I thought I'd throw the floor open to questions.
Cool, thanks. I mean, my first takeaway is Frederick Taylor as a hottie is going to be my second key takeaway for the day. That was not on my bucket list for the day. But
it's the smouldering good looks, it's not twinkle in his eye. Yeah.
I was thinking of a relationship with Taylor Swift there, like a Swiftie kind of world, but yes. We did have a few. So the first one is, I guess in your role, firstly, awesome talk as usual, by the way. Really hope people enjoyed that. I think, the ability to take a lot of very complicated concepts, as I said at the beginning, and reduce them down is always brilliant. But in your experience, obviously, previously consultants thought works are now sort of independently. what sort of things, capabilities are you looking for and characteristics in teams when you firstly sort of start suggesting they maybe start looking at microservices, and B, also when they should start looking at packs? And from my own personal experience, just give this is sometimes people find out I occasionally contribute to Pack Python or whatever, and they say, oh, we should use it straight away. And I kind of like back off and like, hey, you haven't done these things. So I was just curious to hear what your thoughts are. When's the right time to sort of, that next step? Because I don't think it's always the first step, as it were, in that journey.
Yeah, I mean, so if we talk specifically about microservices, I describe it as an architecture of last resort, which is microservices are a means to an end. You've got a problem that you can't solve with your current architecture. Try solving it in all the simple ways first, and then you can look at microservices. So if someone comes to me and says, should we do it? I'm like, what else have you tried? Because microservices as a concept are never the low-hanging fruit. I think then the next step on beyond that is talking generically about any situation where you have interfaces between separate components. This could be between microservices within an organization. This could be between APIs with external parties or whatever else. Then that's the next question, is the interface situation. Obviously, microservices drastically increase the number of explicit interface points that aren't covered by compilers and the like. And so then the conversation comes around the contract testing stuff. I think the challenge around contract testing is that it does require ongoing interaction from both parties. It's a bit of a high trust, but no, it's an ongoing conversation and an ongoing dialogue for, I think, it to work well. And I think if you're creating a public-facing API that's going to be used by 20,000 people, you're not going to have 20,000 people constructing those consumer contracts for you. You might decide to use those yourself as part of your verification process, but that for me is not the kind of the immediate use case. So it feels to me that that interface, that use of consumer-driven contracts, is something that works in a situation where you do have two parties that want to work together. Otherwise, if I were as a producer say, I want to do consumer-driven contracts, but none of my consumers are on board, I'm like, well, this is not going to go anywhere. And so that's kind of it. Now, I think that's kind of why I've started talking a bit more about using explicit schemas, because I feel that people doing nothing, they're doing end-to-end tests, and that's it. And so then if I start talking about the consumer-driven contract idea, which does imply a shift in thinking and a shift in interaction models in terms of your agreements, that's almost a cultural change that needs to happen. And that can take time. And so that is a tough sell for a lot of organizations where they think the people calling their service are, smelly poo-poo heads or whatever it might be, right? So like, actually for me, sometimes, have you tried looking at using schemas? Not as a way of saying that's better than consumer contract testing, but basically as a way of starting to get slightly more formal and slightly more grown up about that service design. I also think getting them to have conversations about SLOs is also helpful. A lot of focusing on SLO conversations are about things like uptime and speed and latency, the non-functionals. But that incorporated into that should also be an understanding about things like how much backwards compatibility can I expect? If you do need to bring in a breaking change, how much time will I have? What kind of verification can you do? Because if you're operating in an environment where I want you to write tests for my service, that's benefit both of us, that should be part of those conversations. And like an SLO is effectively a concrete artifact to that conversation, every bit as an explicit schema or a contract test is. So yeah, there's a lot of grown-upness that needs to happen, I think, around that. And I'm not going to lie, when I've run in some organizations and they've just got 2 or 3 services or whatever, I'm not going to push them away from end-to-end tests at the beginning. I'm going to tell them this is not going to work long-term. But if it's working for them at the moment, I'm going to tell them about the things that are going to start going wrong and let them know to look out for them, and then tell them when that happens, this is what we're going to go do. But yeah, it requires a degree of maturity that I just don't always see early on.
Yep. It's a good point about the public API. I've seen that personally a lot as well, where, and this, I think it's an interesting section with traditional QA and engineers with something like Pack, right? Is it an engineering tool or is it a tester tool? And the truth is it's a little bit of both, I feel. And sometimes, this is my personal experience on sort of public API, and I know Matt Betterman will probably agree with this, if you've got a public API with a version with public consumers and 10,000 consumers, you're not gonna, it's not gonna work contract testing. If you want to use it as testing tool, that's for your internal teams. There's probably a pathway for that, but the schema I think completely makes sense for me in that sense. The other sort of follow on from that, I've got a Beth question in a minute, which is because I love UIs, but the pain of failures around the end-to-end testing. That's a really good point as well, because I agree as well. Like there's this seductive path to start end-to-end testing and that sort of journey. What are the sort of breakpoints for you, and how do you get teams to start thinking about okay, you need to do the next scene when you're working with them?
I mean, there's the issue is, I mean, is that, again, Beth used one of my favorite phrases in the early Q&A, talking about the boiling frog. I think, unfortunately, a lot of the time tests become the boiling frog. What happens is that the cost of creating and maintaining your end-to-end test increases, but the value decreases. And that's not something you're going to see overnight. So for me, often the easiest way to kind of break that out and make the conversation, shift the conversation to a different level, is to talk about coming back to why microservices, right? So you want microservices because you want to release things independently, deploy and release things independently. Okay, but your end-to-end tests are bridging across teams. Who owns those end-to-end tests? Who's responsible for those end-to-end tests? That whole workflow ends up limiting your ability to be independent, putting aside all the other challenges with end-to-end tests. So actually often approaching it from the point of view of, you want end-to-end tests because you want to be autonomous, but so you want microservices because you want to be autonomous, but your use of end-to-end test is undermining that goal. So it's often easier at that point to have that breakpoint conversation, which is, what do we do about that? And so an obvious thing is to start saying, okay, well, we're going to move to a model where we only do kind of large scope integration testing within a team, right? We break away from a multi-team end-to-end tests, which often requires external teams doing testing, which you also is a dysfunction. Let's move to saying, look, let's just try and get each team doing end-to-end testing. And then you certainly find that those teams don't feel like they need to end-to-end testing, right? But I find it's often that circuit breaker. I mean, you can, of course, do the toil stuff. You can actually track the time spent on these things. And I think the other challenge, again, is the boiling frog, is that an awful lot of the kinds of failures you're going to see are only going to happen once you're in prod. There's a wider variety of weird things that are going to go on that become increasingly difficult for you to reproduce in your end-to-end tests anyway. And so you're going to have to get good at that, at doing more stuff in production anyway. So it's also a little bit about saying, we are going to, we're not just going to rip those end-to-end tests away. We're going to ramp down our effort and ramp up our efforts in other places, and you'll get a better outcome from that. But that organizational dynamics one, I think, tends to be the most common one I can use to snap that conversation into a new vein.
Yeah, I agree. The social technical side of it is a challenge. We've got JB Rainsberger on later, and I know he's going to talk about some of the maths behind why these things don't scale. I have to ask Beth's question, because we all know she loves JavaScript and front-end development. So she wants to know how, so you mentioned the front-end monoliths and the SPAs and the world that's taken over. How do you go about recommending to teams to break that down? What sort of techniques and technologies do you see that are being successful in that space?
I mean, I think the fundamental challenge is often when you start having that conversation, they've already got an existing UI. And there are UIs that are amenable to decomposition, and there are UI designs which are not amenable to decomposition. So that is often just a hard break. So if they've got something which can be componentized to an extent, you can see that rationally it's doable. I'm open to it. So with single page app tank, you're basically saying, we're going to do single page apps, but we're actually going to do the micro front end thing, which is basically we're going to have multiple single page apps in a single page, which are just further breaking the brain there. So that is the model, right? For people that have already ill-advisedly gone down the single page app route because you hate the web and everything that Tim Berners-Lee stands for, you horrible people. Right, so if you've done that and you're not building a web page or a website, you're in that world. So there you're looking at the micro front end stuff. So there you'd have a container, basically application. You're putting in the multiple single page app components, and effectively what you end up doing normally is creating like a virtual message broker, almost message bus inside the browser for allow communication between the panes. Now, the good thing about that is it means that you can actually, you're not sort of locked into one single page app framework, and you can actually do part. You could even say it's all React, but I can have different versions of React in the same browser pane, which is kind of cool. But the downside is that can be a bit of a heavy lift. And as I say, some UI designs are not created in such a way to allow for that, because you might have to tweak the design to do it. I would think native applications are a bit of a different fish. Like if you're building native iOS and Android applications, I'm not as close to what you need to do in that space. So I'm probably going to just demur at that point and say I plead the fifth on that one. Because normally I just email Stu Gladow in Australia and he tells me what to say. And then I say, I think this, but it's really just what Stu told me.
Yeah, I don't get me started on mobile apps. I have no idea either. Yes, I know there's some extra challenges just by the nature of the build. I know some new technologies. I know there's React Native and Dart and stuff. I do think allow you to modularize a little bit better. But I think some of those you end up with that. Yeah, by the nature of the beast, and you've also got the idea of an app store as well, which adds an extra layer of complexity, right, when you're deploying to those. A great comment from Frank comments. Coaching consumers through the must-ignore pattern and being tolerant is also a journey, which I think you probably echo. And then you mentioned RPC frameworks being problematic. I do remember the dark days of SOAP. Trying to explain that to a young developer today, that the joys of SOAP is it's a nightmare. Would you mind elaborating this? How does something like gRPC fit into this, basically? Like RPC is a slightly different model. I think they're schema driven. I assume you're probably going to touch on that a little bit. I know we have a lot of internal questions in the maintainers chat about what we do with different sort of technologies like this.
Yeah. I mean, firstly, gRPC is a really good RPC implementation. Like if you want to do RPC, it's the best widely used and widely supported RPC implementation out there, in my opinion. There's some benefits just because of the fundamental nature of the technology, right? JSON is rubbish for sending around between computers. It's an awful format, and it's bad for humans, right? It's bad for the planet. Whales die when you use JSON. So there's a benefit to using binary protocols. And we have to recognize, of course, that with a microservice architecture, we get very chatty communication. A single call coming in from the outside world could kick up a fan of calls internally. So this also then leads us to situations where we might want different communication protocols for what we traditionally call our north-south versus our east-west communication. So gRPC's found a bit of a nice space inside organizations because inherently it's quite fast. It was built to run on top of TLS and makes very good use of HTTP as well. So all your normal routing stuff still applies. So with gRPC, you have to define a schema. So you have to say, this is the way I'm going to communicate. These are my methods. These are my messages. These are my types. And then you basically will generate clients from that. Now, some people see that as a limitation, and I see the point, but there is support in the protocol for backwards optional fields. I mean, I'm almost surprised because I also used the precursors of all this stuff inside Google, and it works really, really well. One of the benefits I like of the schema is really, really good inter-language interoperability and also client-side code generation for client-side stubs. That, I think, is a massive benefit. An awful lot of organizations are doing schemaless REST. They're sending JSON over HTTP, and then they don't have to redo all the work for clients to write their codes. They create client libraries, and the client libraries end up becoming massive points of coupling. So I like just solving that problem, moving away from it all. It is not REST, right? It is a REST, but most people doing REST are not doing REST. So let's get that one out of the way. Yes. So I think it's great, and I think it's and I think schema format is much simpler and leaner because it's a schema. The schema is always there from the beginning. It's not like with the Open API format where they're sort of having to kind of come up with a schema definition afterwards, which is a bit more of a messy space.
Yeah, very good both sometimes, yeah. And the last thing, and I'll let you go, is this is for our budding authors out there. Writing a book, especially one as influential as building microservice, is a noble feat, great language. When did you decide that was something you needed to do, and any advice for budding authors in the audience? I liked writing. I always liked writing. And so that's the key thing. I've met a lot of people that want to write a book, but they don't actually want to write a book. They want to have written a book. And so I eased up to it, right? I contributed a chapter to a book. I wrote lots of blog posts. I wrote lots of things in huge volumes internally inside ThoughtWorks. I
I've never not enjoyed the process of actually sitting down to write. Honestly, that's it. So I think if you want to write a book, start by writing something and by finding out, do you like writing? Because ultimately you might be one of those people that's got some great stuff to share, but writing isn't for you. Don't be dispirited by that. Find the other thing you want to do instead. I just enjoy the process. And that's that. I mean, there's no magic answer. If you want to write a book, don't start by writing a book, write a blog post, do a Substack, something. Just get in the habit of writing, learning, finding your voice is really important. I was quite lucky by the time I wrote my book, I sort of found the way to put me on the page. So that's it. Just you write a book by getting good at writing. You don't have to get good at writing. Just get to the point where you know how to write in a way that you enjoy. But yeah.
Awesome. That's great advice. Thank you for your time today. Brilliant talk. Good to catch up with you again. I'll try not to be so stalkerish next time. And hopefully Bunnies go a bit better next year. They went all right this year, so we'll see.
Oh, we'll get there. We'll get there. All right. Well, good luck for the rest of the day, everybody. And thanks so much for having me.
Cheers. Thank you, Sam. Bye.
Bye-bye.